NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams. And all these little dots are stars?
All these little dots are galaxies, some of which are bigger than our own.
Breaking news. We may have just found potential evidence of intelligent life beyond Earth.
This is a huge discovery, and we think that it's a huge discovery. And that's the most exciting piece of this telescope, of this remarkable instrument we put in space, is finding things that we didn't expect, that we can't explain, because that means that we have to revise our understanding of the universe.
Well, JWST is so phenomenal that if you spend enough time, you could probably find any galaxy that ever formed in the universe. It's really that powerful.
For quite a while, people have envisioned what life might resemble in different universes. Due to the James Webb Space Telescope, the most surprising telescope in existence, that question can at last be examined. While observing the nearest star system to us, Proxima Centauri, which is just 4 light-years away, researchers have noticed several exceptional peculiarities from one of the planets in the system, Proxima b. These peculiarities, called artificial lights, have puzzled the greatest minds in the field of science. But what are they? Do these lights suggest the presence of intelligent life? Join us as we examine the James Webb Space Telescope's unsettling discovery of city lights that could change everything. The only life we are currently aware of is on Earth. Since the beginning of human development, people have wondered whether there is life elsewhere in the universe. To conduct such an interstellar search, American cosmologists Jill Tarter and Thomas Pearson launched the Search for Extraterrestrial Intelligence SETI project in 1984. The goal was to gather space-borne radio transmissions. Radio waves can travel farther and are, therefore, more likely to be detected by the 42 radio telescopes that make up the Allen Telescope Array in the Californian foothills. However, until a few decades ago, no significant extraterrestrial transmissions had been found. Following that, the James Webb Space Telescope's successful launch helped the quest reach a new level by identifying elusive planets orbiting distant stars. As the largest telescope ever built, floating about 1 million miles from Earth and equipped with highly sensitive sensors, it has the potential to make groundbreaking discoveries. Decades ago, no planets outside our solar system were known. However, since then, over 4,000 exoplanets have been discovered orbiting various stars. According to NASA, the universe could contain trillions of exoplanets. The earliest signs of life beyond our solar system might come from extraterrestrial vegetation. The Galileo spacecraft on its way to Jupiter turned its instruments back toward Earth and detected a clear sign of plant life by observing the vegetation red edge, VRE biosignature, a combination of red and infrared light reflected by plants. For instance, a planet like Earth, covered in vegetation, should have a strong and identifiable signature. The JWST will measure the VRE of faraway Earth-like planets in the habitable zones of stars, which could provide significant clues about the exoplanet's atmosphere. When starlight crosses a planet's atmosphere, the JWST can detect it through spectroscopy. Missing wavelengths of light, absorbed by specific molecules and atoms in the atmosphere, create a unique fingerprint that the JWST can recognize. This method can determine the atmospheric composition and assess whether life is possible. Life might exist on Earth-sized planets with atmospheres similar to ours, characterized by a mix of oxygen, nitrogen, and carbon dioxide. By searching for elements that don't naturally occur, we may even detect intelligent life. For instance, chlorofluorocarbons, CFCs, used in refrigeration and cleaning products, could be detectable by extraterrestrial observers examining Earth's atmosphere. If the JWST identifies CFCs in the atmospheres of distant planets, it might indicate the presence of life. However, life on exoplanets might not resemble life on Earth at all. Sometimes, even typical living organisms, such as extremophiles, species that survive in conditions where other life forms would perish, may appear alien. This group of life forms, mostly microorganisms, can survive in extreme conditions, such as temperatures up to 250 degrees Fahrenheit or acidic environments with pH levels below 3. Since planets like Earth are more likely to support life than those with extreme conditions, it would be wise to focus first on such candidates. These planets would have temperatures that allow liquid water to exist on their surfaces and orbit stable stars. Our Sun is a yellow G-type star, but such stars are less common and have shorter lifespans. In contrast, red dwarf stars are more common, cooler, and dimmer than our Sun. Their longer lifespans allow enough time for life to evolve and develop into complex organisms. One promising candidate is the TRAPPIST-1 planetary system, located about 40 light-years from Earth. It orbits a quiet red dwarf star and contains 7 Earth-sized rocky planets. 3 of these planets, situated in the so-called habitable zone, could potentially have liquid water on their surfaces. Despite its smaller and colder mass compared to our Sun, the TRAPPIST-1 star emits light similar to Earth's due to the close orbit of its planets. The clearest opportunity to observe city lights beyond the nearby solar system is Proxima Centauri. A red dwarf star located 4.25 light-years from the Sun. Proxima is much fainter than the Sun, so any planet supporting life would need to be much closer to its star than Earth is to the Sun. In view of fluid water, in August 2016, cosmologists found a planet with 1.3 Earth masses in the habitable zone, a Goldilocks-like zone where the light power is perfect for dissolving water. Proxima b circles Proxima Centauri, yet the fact that Proxima b is tidally locked makes it a potentially airless, dead planet. Since it circles its red dwarf star at just 4.6 million miles away, this close orbit exposes it to strong solar winds that can strip away its atmosphere. However, Proxima b receives sufficient light for temperatures and liquid water similar to those on Earth due to its proximity to the star. Proxima b is believed to be tidally locked, meaning it always shows the same side to the star, much like the Moon does relative to Earth. Proxima Centauri is about 18% the mass of the Sun and emits significantly less light than one might expect for a planet so close to the star, about 5% of the Sun's energy. This might make Proxima b seem like a desolate no-man's land, but liquid water could exist if the planet has an atmosphere to retain heat. Since the total energy reaching it from the star is only 65% of what Earth receives, the planet is not particularly hospitable for life. It is likely tidally locked, meaning it always faces the same direction toward the star, creating a permanently hot side and a cold, dark side with extreme temperature variations. The planet also receives over 400 times the amount of high-energy radiation as Earth, including X-rays and ultraviolet light, due to its proximity to Proxima Centauri. Proxima b is also bombarded with high-energy particles during star flares. Unless it has a protective magnetic field like Earth's, conditions may not be suitable for life. Despite these harsh conditions, Proxima b might still be a more habitable world. Unfortunately, models suggest that the atmospheres of tidally locked planets may deteriorate quickly due to the freezing out of volatile gases on the night side. On Earth, volcanic activity replenishes the atmosphere, and for planets with strong magnetic fields, their atmospheres are less likely to escape. Since we know nothing about Proxima b's volcanic activity or magnetic field strength, we cannot even guess whether the planet has an atmosphere. However, since an atmosphere suggests the possibility of life, we are eager to know if Proxima b has one. It could have solar panels covering the day side to generate power to light and warm the night side, which would otherwise be too cold and dark for habitation. The discovery of Proxima b has triggered a race to determine whether it crosses its star's face as seen from Earth. These transits would allow scientists to determine the planet's size and mass, helping them estimate its density and confirm its rocky composition, providing information on the materials used to form those rocks. During a transit, starlight could reveal the nature of the planet by passing through its atmosphere. However, the likelihood that the orbit is aligned perfectly for scientists to observe a transit is only 1.5%. The star's tendency to flare further complicates matters. Astronomer David Kipping of Columbia University says the star is unstable. As stellar heat makes a rocky planet absorb sunlight and re-emit it as infrared light, rocky planets produce a distinct kind of infrared radiation from stars like Proxima Centauri. Moreover, the James Webb Space Telescope, JWST, was specifically designed to observe infrared light. Proxima b's infrared signature is crucial for detecting the planet's atmosphere. Additionally, the infrared capability of the JWST, which surpasses the Hubble Space Telescope, could allow it to detect city lights on the night side of the planet, even if they are as faint as those currently used on Earth. The JWST could identify artificial lighting as long as it is confined to a frequency band much smaller than the star's light. Proxima B's day side may be heavily covered with solar panels reflecting starlight. As Proxima B circles its star continuously, the day and night sides are vastly different, with extreme temperature contrasts between them. The temperature difference depends on whether the planet is entirely composed of exposed rock or whether atmosphere and water circulate heat. If there is no atmosphere, Proxima B's day side and night side temperatures will vary more, as the day side will emit all the energy it receives from Proxima Centauri as a black body. The night side would appear to be a frozen wasteland. If the temperature difference between day and night is less pronounced, we can speculate that the planet has an atmosphere that redistributes heat. Future space exploration and the search for life beyond Earth hold immense promise, and the James Webb Space Telescope, JWST, may be key to discovering extraterrestrial life in the universe. As the JWST searches for exoplanets, it will ultimately help shape our understanding of other worlds and our own. The search for extraterrestrial life has taken a leap forward with the capabilities of the JWST. While we have just begun to scratch the surface of what it can reveal about planets in distant star systems, the discoveries made so far offer tantalizing glimpses of what might be out there. As we continue to observe exoplanets like Proxima b and others in the TRAPPIST-1 system, the potential to detect life, or at least signs that life once existed, grows stronger. Even if these planets do not currently harbor life, studying them will help us understand the conditions necessary for life to thrive. Each new discovery adds another piece to the puzzle of how life could emerge in the universe. In addition to looking for biosignatures like the vegetation red edge or atmospheric components such as CFCs, scientists are also investigating more subtle signs. Artificial lights, for instance, may not be the only indicator of intelligent life. Variations in the planet's radiation or unexpected patterns in its magnetic field could also signal more than a natural environment. The JWST's ability to detect and study these anomalies will provide a wealth of information about the potential for life beyond our solar system. The possibility of intelligent life existing somewhere in the universe remains one of humanity's greatest questions. The discovery of something as complex as city lights on a distant planet would be a game-changer in the search for extraterrestrial civilizations. Even if the evidence is circumstantial or indirect, it would prompt a re-evaluation of the uniqueness of life on Earth and the potential for other civilizations to have developed in distant parts of the universe. Looking ahead, the JWST's role in uncovering the secrets of distant planets is vital. Its ability to observe exoplanets more precisely than ever before, particularly in the infrared spectrum, will allow us to analyze atmospheres, compositions, and even potential signs of life on planets light-years away. With its unmatched precision and sensitivity, it may only be a matter of time before the telescope detects something truly remarkable that confirms the presence of life elsewhere. As scientists continue to monitor planets like Proxima b and explore the possibilities of habitability, we are on the brink of potentially rewriting the story of life in the universe. The era of space exploration and extraterrestrial discovery has only just begun, and the JWST will be at the forefront, guiding humanity toward new frontiers of knowledge and understanding. Ultimately, whether we find artificial lights, biosignatures, or other signs of life, the search for these discoveries enhances our understanding of the universe and our place within it. The search for life beyond Earth is not just about finding others. It's about learning more about ourselves and the incredible complexity of the universe. Through the eyes of the James Webb Space Telescope, we may soon answer one of humanity's most profound questions. Are we truly alone in the universe?